Hello friends, I am Yashdeep Shah and I am here to discuss on the topic ls, that is listing directory contains, and also some of the basic questions of UNIX. So let us start. Firstly, we will discuss ls. What is ls? The ls is a command in UNIX which is used to get a list of files and directories. It has so many options that can be used to get additional information about the files. Firstly, we will look over the syntax of ls. ls syntax is look like this. Firstly, we will write ls options and then path. Here the options are not necessary to write all the times. These are depend on the need of the user as they want. And the path will have the name of the file or the path of the file on which we want to apply this ls option. Let us try this on terminal. Firstly, we will get to our, so currently we are in desktop. We will apply ls here. So here we will get the link of the list of all the files that are present in our desktop directory. So this is how the ls command works. Let us look over the options that the ls provides us, or the ls command that supports the following options. First, ls space -a. It will list all the files including hidden files. They are the files started with dot or double dot. Let us try it here. So we can easily see the difference that here there are two more files, that is dot and double dot. These are the hidden files that are shown just by the option ls space -a. Now next option, ls space -l. It will list the files in longer format, that is with the index number, owner name, group name, size and permission, like ls space -l. Here there are total 7 attributes here in which we will get our output. Firstly, the permission of the file. Here the number of the links that are associated with the file, name of the owner, name of the group associated with size of the file, the last modification date of the file, and the name of the file. So the ls space -l will show us a brief output of all the files that are present in our directory. Next, ls space -o. It will list the files in longer format but without the group name. So let us see the difference between ls space -l and ls space -o. So here is the difference. Here the group of the name is none, but it is visible, but here the name of the group is omitted because we had used the option ls space -o. Now next option, ls space -i. It will list the file along with their index numbers. It is the index number on which our file is present in a hard disk. So here it is the index number and the name of the file. It is this output for all the files that are present in our desktop directory. Now, next option, ls space -ls. It will list all the files along with their size, but remember, not in the sorted manner. It will just give us the output like the size of the file and the name of the file. Now next, ls space -t. It will sort the list by time of modification with the newest at the top. That is, here you can see the file that I had opened recently, and at last the name of the file that is rarely opened on this PC. So the -t used to, we can say, sort the file in a manner of their modification. Next option, ls space -S. It will sort the list by size with the largest at the top. Here you can see the difference between the small s and capital S. That is, it will show the files according to their size, but it will not mention the size. So if we use both the commands, so we will get the size but in a sorted manner, size along with the name of our file and also in a sorted manner. And this is how we can use two options at once. Next is ls space -r. So to understand this, we will use it just with the above output. So you can see here the difference, it is sorted in according to the size from higher to lower, and it is just opposite of the above output, because we had used here a small r which is used to reverse the output. So next option, ls space dash g, it will list the files in longer format but without the owner name. ls space g, to find the difference we will use l also here. Here you can see the difference, that it is permissions link, but the name of the owner is not visible here, because the dash g is used to remove the owner name or not to display the owner name with other details, and other than that all the details are similar as ls space dash l out. Next, ls space dash capital F, it will mark the directory with slash and executables with asterisk. It is used to distinguish between the directories and the executable files. Like here we can see that this file is executable, whereas this file is a directory, means it can have more files in it. To confirm this, we will use it space okay. So you can see here, yeah, it has two more files in it. So here it is confirmed that the slash is used for the directories, whereas it is used for the executables. Let us get back to our parent directory, it is desktop. Okay, now the another option, ls space dash x, it will list the output in a multi columns. Here we cannot see the difference easily, but just to show this option I am using it here. So you can see the output in columns like this. This is the use of this option. And the last option, ls space dash d space dir name, it will list the dir name only if it is present in the directory. Like we'll see here that we have one of directory my app. Let us search for it. It is showing in output my app because the my app is present in the desktop directory. But if we will search for any directory which is not present, like my, because my is not there, let us see the output, and it will show us output like cannot access my, no such file or directory is present. Means this command is just used to check whether the directory is present or not. Let us discuss test your understanding questions. So question first, write a script that accepts a compressed file name as argument. It looks the extension and decompresses the file using the current decompression program, but only if the decompressed file doesn't exist. So according to question, we have to first write a script which accepts the file names as argument. The file name could be of .gz, .bz2 or .zip extension. It will look for the extension and decompresses it. If it is decompressible or if it is decompressed, then we will show it, or otherwise we have to show it doesn't exist. Let us start. Firstly, we will use the $hash. The $hash is used to set a specific argument, and we will check it with 0, that is $hash is equals to 0. If the argument is equals to 0, then we will use here, we are using here AND. The AND works in such a way that if this bracket will be true, then only the second one will execute. So according to this, if $hash is equals to 0, means the file is not there, so it will echo usage $0 file name, that is $0 will return us the return value and it will exit. Now we will go for the cases, because we have 3 cases in it. Firstly, .gz, .bz2 or .zip. If there is first case, that is .gz extension, then we will assign the following values, that is in program g unzip to u file name base name $1.gz. Here $1 will give the first parameter, the value of the first parameter that we had written here. Now similar for .bz2 and .zip, it will also allow the program the u file name this like this and similar here. Now we will close the case here. If here -f u file name, -f is used to determine whether the file is regular or not, or the and here the $u file name will give us the value of from the three cases above that we have used. If this is true or this condition satisfies, then echo uncompressed file, the name of the file exists, or else the program $1. That is $1 is our first argument that we had used, and we will close here file. This is how we'll get our output. Go to next question. It is write a shell script that searches for a pattern in all files in the current directory and then calls up the VI editor with those files containing the pattern. How will you repeat the search in the current file and other files? So according to question, we have to write a shell script that searches for a similar pattern that we had given to it, and if the file is present, then it will call the VI editor for those files or the files that containing those patterns, or to find those files. So here we will go for it. Firstly, we will use this script. The script is here that pattern equals to $1. Here we are assigning the value of $1 to pattern. $1 is our first argument. Here set is used to set any of the value for the given program. Here we are using set grep-l $pattern. Grep-l, it is used to find for a similar type of pattern as we have given here, that is $pattern. So $pattern will have the value of $1, and it will list the similar type of files which will have the $pattern type of value in it. And at last we will use $hash. $hash means that specified argument, if it is greater than 0, if the specified argument is greater than 0, and if this is true, then AND will execute and it will call the VI editor, and in VI editor it will go for the $pattern value of $pattern, that is whether the similar type of pattern is present or not. And here the $@, it is used as an argument of a string, that is in $@ whatever we will write, it is executed as a string as a specific string. If this will execute, then only this will execute. But if we are not able to find any of the pattern, then this OR will execute and we will get our output like echo $1 not found, that is the pattern that we are trying to find is not present in our directory. Okay, so and to repeat the search in current file and other files, we will use :n. It is used to call up the next file, and n command to locate each occurrence of the pattern, and repeats the last pattern search in VI. Third question. Explain whether this while loops will run. First, while 5. Second, while x $1 not equals to x. So while 5, we can easily see that here is no condition, so it will run for an infinite loop. It will go for an infinite loop and without any condition. So here it is the answer that both execute and in infinite loop first unconditionally, because it doesn't have any condition in it. And in second, x will have, x is, you can say, just a variable with $1. $1 is the first argument, or the argument that we had passed is not equals to x, so it will only work when you have no argument. But here you had passed $1, that is it should have a argument in it, so obviously it also not execute and will go for the infinite loop. Next question, write a script that accepts file names as arguments. For every file name, it should first check whether it exists in the current directory and then convert its name to uppercase, but only if a file with a new name doesn't exist. We have to write a script again to accept file name as argument, and we have to check the file is present or not, and if it is present, then we have to convert its name to uppercase. Let us go for it. We will write here for loop. So for file in $@, is used for a specific argument. So whatever we will pass here will be treated as a specific string. So if for file in this, we will do what we will do if $f $file, that is if the $file, the value of $file is a regular file and it is present. If this condition true satisfies, then it will give the value of echo $file pipe tr a small range small a to z space range capital A to Z. It will so look at the output. What it will give? Firstly, it will echo $file, that is echo the value of $file, and the output of this will act as an input for this expression. And in this we are doing translation of small letters into capital letters. So it will give us output, and it will provide this in the U file. Now we will check for U file. If -f U file, that is whether the U file is a regular file and it's present. If it is true, then it will echo that $U file, the value of $U file also exists. Else it will move $file to $U file. After this loop executes, we will close the loop with $fi, the reverted order of if, and if this loop won't execute, so we will go for else. In else, we will echo that file doesn't exist, and we will close here the if, and just done with the command, done. So here by this we will get our output. If we have the file, then we are translating its lower characters to upper character, and if it is not present, then we are echoing the answer that $file, that is the value of our file, doesn't exist. The last question, devise a script that looks at every component of path and check whether the directory exists and is also accessible. We have to write a script for a component of path, that is for a path to check whether directory exists or it is executable, that is accessible or not. So here we are using some IFS. What is this IFS? These are internal field separators. These are used just to separate between our different directories, paths, files, and all the options that are available in the Unix. So we will start from here. Old IFS, we are creating a variable old IFS, and we will provide the value of IFS into old IFS, because now we are changing the IFS. So our previous IFS will work as old IFS, because we are now modifying the values. Here IFS is blank now, so we will set is used to just set a variable or the value for the specific program. So we are using set $path, the value of the path. We are setting the value of the path for this specific program. Now we will use for loop here. So for directory in the $@, as you know now why it is used, because it will act as a specific string. So if we will use for loop in this. Now for loop we have to do that if in if command, if not -d $directory. -d is used whether the file is a directory or not, or a regular directory, or a executable directory, or a present directory. So we will use -d. So here we are using -d $directory, but with a not symbol. So if it is not a directory, then we have to echo $directory doesn't exist. But now we will use else with if, that is elif. In elif we will use again with a not symbol, but this time dash x dollar directory, that is the directory is executable or not. Dash x is used for the executables. So if directory is not executable, then echo directory doesn't have search permission, because the directory is only accessible to or executable when it have sufficient permissions, but we are using here not. So if it has no permission, then it will echo the output that dollar directory doesn't have such permission. Let us close the if condition here and just complete this command with done, and redirect our or send our value of the IFS to it, that is old IFS in the previous IFS. We had changed the value of IFS here, and we will now restore the old value of IFS. So this is how we will end our session. So thank you so much. Stay home, stay safe. Thank you.